Alright, so here we are with Unit 11, Lesson 11, and we're going to cover two compounds. We're going to cover ethers and then aldehydes. So let's take a look first at ethers. Um, if you look back at Table R, and we'll start with this one, if you're given this compound here, first thing you know that it's not an alkane or alkyne because it has this oxygen. So right away you go to Table Table R, and you look for which one of the ones on Table R has an oxygen somewhere in the middle. It's not double bonded, and that leads you to an ether. And ethers, basically what you do is you split where the oxygen is, and then you name the two pieces that are on each side. You treat them as kind of branches. When you have two carbons, it's called an ethyl group. Notice that you have an ethyl on each side. So you would name this diethyl ether. Okay. Next one is you have methyl and ethyl. So now you have the oxygen in the middle. On one side you have the methyl. On the other you have the ethyl. It doesn't matter which you put on either side. I'm going to put the methyl here. And then the ethyl goes here. And then put the dashes to represent the bonds that go to the H's. Remember, every carbon has to have 4 bonds, but each oxygen can only have 2 bonds. Next one is butyl propyl ether. So again, there's not going to be much room here. Here's the oxygen that identifies it as an ether. I'm going to put the butyl here, means it's going to be 4 carbons, 2, 3, 4, and it's going to have all these bonds around it. It's not going to really fit well. And then you're going to have propyl, which is 3 carbons, 1, 2, 3, and these will have bonds around it, sorry. And that's butyl propyl ether. And again, it doesn't matter whether you put the 4 carbons on the left side or the right side, because they're all 3-dimensional. Alright, let's go on to aldehydes. Alright, so aldehydes. Now, you have to be careful because they do look like an organic acid. Here's the functional group that you're looking for. Notice it has just one oxygen, and the aldehyde, the functional group, is always at the end. That distinguishes it from the other ones on Table R. Aldehydes all end in Al, and they're relatively easy to name. You just put, if you look for it, you see it ends in Al, so right away you know it's an aldehyde, and it has a 3-carbon chain. So you put 3 carbons, 1, 2, 3, and then the third, it doesn't matter, it's always at the end, so you know it's going to be either this carbon or this carbon, and I just put the double bond O, and then the H, and that's it for the bonds for carbon because it already has 4, but these need more, and that's propanol with an Al. Now this one has 1, 2, 3, 4, 5 carbons, so that's based on pentane, and since it's an aldehyde, I replace it with an Al at the end, and that is pentanal. I guess we can do ketones because it's a relatively short video. And then we'll do the next ones. Okay, so here we have ketones. Now, if you look at the ketones, it looks similar to an aldehyde. If you look at this here, it has the carbon double bond, but notice that the carbon double bond is in the middle. It's not at the end. So that tells you that it is a ketone. The names of ketones all end in O-N-E. And you have to indicate what carbon the double bonded oxygen is on. Now, in this particular case, you really don't have to, because if it was not, if there's a 3-carbon chain, you really don't have to put where the double bond is, because if the double bond was here, it would not be called a ketone. If you probably put it, it would probably be more correct, even though technically it should not be done. Let's do the 2-pentanone. 2-pentanone means that you have a 5-carbon chain, the pentane, right? And the 2 is telling you that the double bonded oxygen is on the 2nd carbon, so it would be either here or here. I'm just going to put it here. And then you fill in the rest of the bonds. This one doesn't need any more bonds, right? Because it already has 4. Okay. Now this one is... Hold on. Sorry about that. Phone ringing. So if you just put this down, this is propane. And change the ending to O-N-E, so this is propanone. You really don't need to put a 2 in front because that has to be where the double bond is, otherwise it wouldn't be a ketone. But if you put it, I guess it would be fine, so it's 2-propanone. And that's it for those.